Hey everybody, Mr. Bowman here. This is another 3.13 probability concepts video, and we're looking at all the achieved questions for that 2021 exam. And this exam was a bit more friendly because it did have a few more achieved questions. So let's start straight into question number 3, which is actually going to flow on to question 4. There'll be a similar kind of context to it. So we've got a music and dance festival selling 2 types of tickets. And they are the early bird tickets or the general admission tickets. For each ticket type, there's basically a child ticket or an adult ticket. So it looks like we've got 2 types of tickets, child or adult. So it could be a probability tree or it could be a two-way table. So I'm not quite sure at this stage what's going to be best. Early bird tickets need to be purchased before a particular date and are cheaper to the general admission tickets. And they're cheaper. For the 2021 festival, 1/5 of tickets were early bird. So we know the probability of an early bird is going to be 1/5. For these early bird tickets, 3/4 of them were adult. So 3/4. So we've got 3/4 over here. So that kind of looks like it's going to be a tree instead of a table, because we would have, the 1/5 there, and then we could have the 3/4 over there. So that's probably where I'm going with this question, I think. 2/3 of the general admission tickets, so that would have been the bottom one, we're going to be adults, so 2/3. So it does look like a tree is going to be good, so let's circle 2/3. The festival organizers predicted 10% of their tickets were going to be child early bird tickets. Was their prediction correct? Okay, well, let's start drawing a tree. So the first split is really going to be the type of ticket, the early bird ticket or the general admission ticket. So let's do my split here. So we've got E for early bird tickets, G for general admission tickets, and we were told over here that 1/5 of the tickets sold were early bird. So we're going to cross it out. So we've done 1/5 over here, which means the other 4/5 have to be those general admission tickets. For these early bird tickets, 3/4 of them were adults. So let's split this off here. These early bird tickets are going to be either adult tickets or child tickets. And we know 3/4 were adults. So if that's 3/4, this bottom one is going to be 1/4. So let's cross out that information. And then down the bottom, for general admission ticket, 2/3 of them were adults. So same split here. We've got our adult tickets and our general admission tickets. We've got 2/3, and then we've got 1/3. So I've got my tree. It's looking pretty nice. So the actual question, 10% of them childhood and early bird tickets. So let's find that probability. So this branch here is going to relate to the early bird and child tickets. So the probability that it's going to be E and C, that's going to be equal to 1/5 times 1/4. That there is going to be equal to 1/20, which is 5%. So this number, a little bit different to the predicted number, probably half of it. So the probability of A and C is 5%, which is much lower than the 10% predicted by the organizers. So that wraps up question number 3. And now moving on to question number 4, which does carry on from the initial question. So I'm just going to sneak it down the bottom there. So calculate the overall proportion of tickets that were adults. So this question, it's going to be a bit mathy, but the probability of an adult, forgive me as I spelled that wrong, will be, if you think of our tree, it's going to be, that's an adult branch, and then over here is an adult branch. It's going to be those 2 branches added together. So this top branch here is going to be the early bird adult tickets. So it's going to be the probability of early bird and adult plus this one down here is going to be general admission plus adult. So that's going to be plus the probability of the general admission and adult tickets. So following the branches, this is going to be 1/5 times 3/4. So we've got 1/5 times 3/4, We're going to add on the next branch, which is 4/5 times 2/3, 4/5 times 2/3, and you can simplify that fraction, or you can bang it straight into the calculator, and I've got 0.6833, and that had a 4 decimal point rounding. Okay, we are now on to question number 5. Sorry about the weird clicking noises. I had to actually stop and redo this question because I didn't draw my table big enough, and it made it end up looking a bit messy, but let's just redo it. So we've got 3 festivals. We've got I, E, and S. So I'm not going to say these names the whole time, but we've got I, E, and S. There are 37 groups in total across these 3 festivals, so that's a total number. And I should note before I move on, actually, because I had 3 different variables, straight away that made me think about my tools where I could deal with 3 variables. So that was either going to be a 3-way Venn diagram or one of those messy looking 3-way tables. So that's where I was going as I read through the rest of the question. And as I go through it, it does confirm it. We've got the total for I, the total for E, and the total for S. We've got I and E, we've got I and S, and then we've got all 3. So straight away, I know for sure it's definitely going to be 3 variables. I personally never do Venn diagrams because sometimes you end up with a bit of algebra needed and it doesn't really work out. So I'm going to go with the 3-way table part of my response. Calculate the proportion of acts at the I festival that are unique. So the wording of this question is actually quite interesting. Let's not worry about the question itself for now. Let's put a big question mark here. Let's get into drawing the table with all the information we've got, which is the main part of the question, and then I want to come back to the question of what it's actually asking. So let's sketch a bigger table. As I learned, I need a lot more room to do this question here. So I'm drawing my horizontal lines. These are going to be my I and not I. I'm then going to chop this in half. And we'll draw our totals over here. So this here is going to be E and not E, and again E and not E. And then finally I'm going to chop this in half. Well, that's not in half, that's close to half, but not quite. We've got S and not S. And then we're going to have some totals around the edges over here. So let's get these total lines sorted. And then we'll draw that line up there. Okay, so let's start plugging in the numbers. I guess the first thing to note is up the top here, we were told there were 37 acts performing across all the groups. So that number there is going to be 37. I'm going to come back to that. There's actually a hidden bit of information in there later that I'm going to come back to. 17 are at the I festival. So I is this lot here. So that number there is going to be 17. So I've used this bit of information now. 14 we're at E. E is a bit tricky because E is actually represented by these 4, and we don't really have a subtotal for that. So what I'm going to do is I'm going to do a bit of coding here. I'm going to put a plus sign in each of these just to help me out later on. So my plus signs at the top here, all of those have got to come to 14. And basically, when I know 3 of them, I'll be able to use that information to find out the 4th one of them by doing some subtraction. So I've used 14, I've done a code for that, and S is 29, so that's going to be down here, 29 at S. So what else can we figure out? We know there's going to be 20 here, and we know there's going to be 8 over here. So let's carry on to the next line. 5 of them are at I and E. So I and E would be these 2 groups here. Again, we don't have either of those, so we can't figure them out. So let's do another code here. So that can be coded as a circle. So my circles have to add to 5 later on. So we'll cross that out because I've now used it. I and S has to be 13. So I and S, that's going to be these 2. Again, I've got the same issue. Don't have the info, so I'm going to need a code. I'm going to draw a triangle and a triangle. And later on, these triangles have to get to 13. So I've now used that bit of information. And then finally, 3 acts can be seen at all 3 festivals. So that's I, E, and S. So that one over here is 3, which is nice because a lot of my codes are linked in with that particular square. So I've now done all the information. I now need to play the game of filling out the table based on my codes. So the first thing you focus on normally is the one where there's 2 codes. So the plus signs have 4. Let's deal with the 2s first. So let's start off with the circles, which represent those 2 boxes. And we know those circles have to sum to 5. So that means this box here is going to be 2. So I've now dealt with the circle code. Looking at the triangles, those 2 triangle codes have to sum to 13. So that means down the bottom there, that has to be 10. So I've now dealt with that triangle code. The plus sign code I can't deal with because I'm still missing 2 of them. I can only use the codes if I'm missing 1. So I've got to figure out some other stuff. Let's start off with the i's. I know the I total is going to be 17. So I'm going to subtract everything from 17, and the leftover is going to end up in this box. So 17 minus 3 minus 2 minus 10 is going to leave me at 2. So when I first did this question a few minutes ago, I got stuck here because I couldn't really figure out enough information here to help me get the plus signs. And I stuck my mind to it, and eventually it clicked that this 37, they represent acts or groups performers who have gone to the 3 festivals. So we've actually been we've been given this number here, which is going to be 0. So this box here represents I dash, E dash, and S dash. So that's basically not going to any of the festivals. But we know these 37 are going to at least one of the festivals. So that means none of these 37 groups aren't going to any of them. So we knew that 0, and that was a bit of a trick there. Now that I've got the 0, I'm going to focus on the S dash column. The total's got to be 8, which means that plus sign is going to be 4. I've now got 3 of my 4 plus signs, which means I can figure out that final plus sign. So I've got 14, minus this 4 is 10, minus the 5 up here is going to get me to 5. And then finally, this middle lot's got to get me to 20, so that one there has to be 11. So that's my table. That was probably the trickiest part of it. The question itself, I said I wanted to go back to the question because it's actually a lot harder than it looks. So calculate the proportion that acts at the I festival. So we know for sure they are at the I festival. It's not a random festival, it's at the I festival. So that kind of sounds like it's going to be one of those blah, 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 something given I type questions. So let's go back to the question. So calculate the proportion of acts at the I festival were unique to that festival. So the box in the middle is basically going to be performers that are only at that festival. So doing my notation, so I'm going to find, well, what's the probability of I, and so not the other one, and not E, given they were at I. So I, S dash, and E dash is going to be I, S dash, E dash is going to be these 2 here, right? So that means there's 2 performers that are going to be unique to the I festival from the 17 I festival performers. So it's not about all 37, it's about the 17 at that I festival, and that's because they were told it in the question. It was a bit hidden, but there it is. So that means the probability here is actually 2 out of 17, which I think a lot of people would have struggled to get that in the pressure of exam, which comes to 0.1176, and that had a 4 dp rounding. Okay, we are now on to question number 26, which I'm writing down the bottom of the page there because this question does carry on from the 3-way table we drew in 5. So I guess the nice thing is we've done most of the mahi from that previous question. So a particular festival attendee cannot afford to go to, can afford to only go to one festival. They wish to attend a festival that gives them the highest probability of seeing a unique act. Which festival should they choose to attend? So a unique act means an act that is only going to that festival. So for example, that would be I, but not E and not S. Or it could be E and not I and not S. Or it could be S, not E and not I. We've been specifically asked for the highest probability. So what my goal for this question is I'm going to find the probability of each of these 3 events separately, and I'm then going to base my decision on which of them had the highest probability. So that's kind of my end goal, what I'm aiming for this question. So I guess the first part of the question is let's list all the 3 probabilities with the notation. So the probability of a unique performer at I, but not E and not S, is going to be, we know the totals are all going to be out of 37 because we had 37x in total. So that's going to be 37 over there. So we have I, not E, and not S. So it's going to be this 2 over here. So the probability of this, or I only, is going to be 2 out of 37, which is 0.0, I've got them written down here, 541. So about 5%. We're now going to move on to E only. So the probability of E and not I and not S. So same thing, it's going to be out of 37. So we have E, which is kind of these ones. We have not I, so that's this bottom half, and not S. So that's going to be that one there. Yeah, so I'll forgive that dash there. That was meant to be E, wasn't it? So yeah, we got E, not I, and not S. Okay, so that's going to be 4 out of 37, which is going to be double that last one. Forgive me as I hit the microphone by mistake, but it's going to be 0.1081. That had a 4 dp as rounding as well. And then finally, the last one, S only, that's going to be S, not I, and not E. So S is over here, not I is kind of over here, and then not E is going to be here over here. So that's 11. That's a lot bigger than the 11 and the 7, or the 11 and the 4 we had before. So it's going to be 11 over 37. And getting that to a 4dp number, 0.2973. So I've now got the 3 probabilities of the unique ones only. So based on all of this, so what festival should they choose to attend? They should go to the serendipity one because they have the highest probability of having a unique performer. So the attendee should go to the serendipity, forgive me if I spell this wrong, festival. There we go. So we're done question 6. We are now on to question 7, which is the final question from the 2021 Achieve sections. And again, you'll notice a common theme, a heap of words here, so let's break them down. So festival tickets, we're carrying on with our last one, can be either sold online or through a ticket office. Maybe that's a variable we could potentially consider. Organisers have gathered data from the first 1,000 festival takers, so that sounds like, oh, actually 1,000 that bought it online. That maybe sounds like the total or the online total. The data summarizes the age of the attendees, so we've got less than 25 or older than 25. That's maybe another variable. And the main motivation for attending the festival. And there we go. So the motivation to us is another one. So it looks like we've potentially got 3 variables here, but maybe this first one's a trick one because we've only got online tickets. So maybe the fact they could have bought it through a ticket office doesn't actually matter here. So let's keep an eye out for ticket office in the rest of the wording of the question. So 750, that's a total there. We're going to need it later on. Are less than 25. The main motivation of these 510 is to dance. The remainder of the young attendees is split between socializing and other. Okay, so nothing about the ticket office there. So maybe I am right about what I said before. Over 25 years old, we've got 160 for socializing, 60% of the rest were for dancing. Calculate the probability that a festival goer is less than 25 and interested in socializing. So I guess the main thing is festival attendee, all 1,000 people here are festival attendees. So it's not a conditional question. So we're trying to find the probability of less than 25 and mainly interested in socializing and socializing. So that's our end goal. So the nice thing is we don't have to consider if the tickets were bought online or at the office like up here, so we can just ignore that. So let's think, I'm thinking two-way table here. I can do the less than 25 people and the motivation for attending people. So let's draw myself a table. So we're going to go less than 25. And then we've got more than 25. And the reasons for attending were dancing, socializing, and other. So we'll go D for dancing, S for socializing, and O for other. And it looks like I'm going to have all my info. So I guess the first thing to note, the grand total of people were 1,000. So I'm going to put that in to my grand total box, 1,000. So I've now used this bit of information. 750 were less than 25, so that's my less than 25 totals. That's over here, 750, which means that there is going to be 250. So I've now got that part used. The main motivation of these, 510 of these were to dance. So these refers to the less than 25-year-olds. So we've got 510 over here. So I've now used this bit. And the remainder of these younger attendees, so I'm still dealing with the 25s, are split evenly. So there's 240 left, and that's going to be split evenly between S and O. So that's going to be 120 and 120. So I've now used that 510, the split part. There you go. So that's been used. So for the older people, so we can now start answering this older people section. 160 are there for socializing. So let's write 160 here. And then of the remaining older people, 60% are there for dancing. So the remaining for here and here, that's going to be 90. So the dancing one is going to be 90 times 0.6, which I think is going to be 54. I'm just checking my notes. Needs to be good, 54. I can now use math to figure out that last one. It's going to be that 90 minus the 54. So that's going to be 36 here. We can then figure out the totals down here. So that's going to be 564. We've then got 280. And then finally, we've got 154. Okay, so we've got all the information. Table's filled out. Let's figure out the question. So probability less than 25 and socialing, that's going to be this group up here. And it's because it's out of all attendees, it's going to be out of 1,000. So let's go probability of less than 25 and social. That's going to be equal to 120 out of the 1,000. Convert that to decimal, 0.12. So I got that there. That one was a bit messy, but we got there in the end. So quite a long video. This one, heaps more achieved questions in this 2021 exam. Hopefully you found them useful. Keep an eye out for the next videos. There should be some merit and excellence ones coming out soon as well.